Hey everyone! Today, we're going to be building a powerful math toolkit, one that'll honestly change how you see problems. We're grabbing 3 huge ideas from the Malaysian Form 1 syllabus. We're talking powers, ratios, and algebra, and we're going to show you how they all click together. Ready to seriously level up your math skills? Awesome! Let's get started. So, right off the bat, you might be wondering, what do squares, ratios, and algebra even have in common? They seem like totally different things, right? Well, the truth is, they're all fundamental tools for understanding the world. They're like the secret language of patterns and relationships. And today, we're going to learn how to speak it. All right, here's our game plan. We're going to start with the absolute basics, the building blocks, powers and roots. From there, we'll get into the art of comparison with ratios and rates, which leads us to understanding proportions. And finally, we'll unlock the ultimate problem-solving tool, algebra. It's a pretty cool journey, so let's jump right in. First up, powers and roots, or, as we say, kuasa and punca kuasa. You gotta think of this as the foundation of our entire toolkit. Seriously, before we can build anything cool, we need to get a handle on this simple but powerful idea of a number multiplying by itself. And that leads us straight to this concept of a kuasa dua sempurna, which just means a perfect square. And the name kind of gives it away, doesn't it? A perfect square is literally a number that can form a perfect square shape. It's just the product of a whole number multiplied by itself. Length times width, where the length and width are the same. Just look at this beautiful pattern here. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9, and so on. These are your first few perfect squares. And let me tell you, recognizing these numbers on sight is like a math superpower. They pop up everywhere, and knowing them by heart will save you so much time down the road. Okay, foundation is set. Now let's add some new tools to our kit. Tools for comparison. We're moving beyond just looking at single numbers and starting to explore the relationship between numbers. This is how we make sense of everything from cooking recipes to checking your car's speed. So in this section, we're going to unpack 3 closely related ideas. Nisba, which is ratio, kadar, which is rate, and kadaran, which is proportion. Think of them as a family. They all help us compare things, but each one has its own special job. First up is nisba, or ratio. This is your go-to tool for comparing 2 quantities of the same type. So, if you've got a mix of 5 red apples and 3 green apples, the ratio of red to green is simply 5 to 3. It's a super clear and direct way to see how much you have of one thing compared to another. Next in the family is kadar, or rate. Now, a rate is a special kind of ratio, and here's the twist. It compares 2 quantities that have different units. The classic example is speed, right? Kilometers per hour. We're comparing distance in kilometers with time in hours. 2 different units. That's a rate. Okay, so we've got ratios and rates for comparing things. But what happens when 2 of those comparisons are actually the same? When they're equal? Well, that's where our third tool, kadaran, or proportion, comes into play. This is all about finding equality and balance between 2 different ratios. A proportion is really just a statement saying 2 ratios are equal. That's it. For instance, if one recipe calls for 2 cups of flour for every 1 cup of sugar, and you want to make a bigger batch with 4 cups of flour, you'd need 2 cups of sugar. The ratios, 2 to 1 and 4 to 2, are the same. When we write them as fractions, it's super easy to see that they're equal. That's a proportion. All right, we've handled numbers and we've handled comparisons. Now it's time to bring out the most powerful tool in our entire math toolkit, algebra. And don't let the name scare you. Think of it less as hard math and more like a universal language for solving mysteries, even when you don't have all the clues yet. So this might look a little complicated, but it's really just a map of the parts of an algebraic expression. You've got your variables, which are the letters, and you've got terms. But really, the most important thing to wrap your head around is the difference between 2 specific types of terms. And this is it. This is the absolute key to algebra. Understanding like terms versus unlike terms. Like terms are easy. They have the exact same variable and the exact same power. So 2x and negative 3x are like terms. But 2x and 6y? Nope. Different variables, so they're unlike terms. What about 2x and negative 7x squared? Still no. Same variable, but different powers. If you can get this one single idea, you've pretty much cracked the code to basic algebra. So, now that we're experts at spotting like terms, we can actually start doing stuff with them.
This is where it all comes together, and you're about to see that it's not that different from the normal math you've always done. We're just combining things that belong together. Okay, let's look at this addition. We have 5a plus 6a. Now, since they are like terms, they both have the variable a to the power of 1, all we do is add the numbers in front. 5 plus 6 is 11, so we get 11a. It's really just like saying 5 apples plus 6 apples gives you 11 apples. See? Simple.
And that same logic totally works for division. Here we've got 36pq divided by 4p. Let's not get overwhelmed, let's break it down. First, just look at the numbers. 36 divided by 4 is 9. Easy enough. Now for the variables. We have a p on top and a p on the bottom, so they just cancel each other out. What's left over? Just that q on top. So our final answer is 9q. And there you have it. We've just built a fantastic math toolkit. We've got perfect squares, we understand ratios, and we can speak the basic language of algebra. Remember, these aren't just random concepts from a textbook. These are real tools you can use to make sense of the world. So the only question left is, what problem will you solve first?